Okay, I think we're good now. Is Zoom sharing my screen though? Stop sharing my screen. Zoom, why did Zoom do that? All right, let me look at my questions that I've gotten since you guys don't have any specific questions. Okay, last, I don't think I did a recording, but last week we did cover two challenge activity 241, 261, and 262 and 263. So let's look at 241 first. That's a good place to start. So 241 has to do with decimal values, and this is a challenge activity. If you've done it already, you can compare your code with mine, because there's more than one way to code it. And if you haven't done it already, then like I said, take a picture, take a screenshot, something, or type or write it in there so that you don't have the same questions. All right. So as you get into, okay, let me reset this. As you get into Zybooks, you'll see that you'll get more experience with how the input works, where sometimes it asks the user, you'll have an input box here, and it'll ask you to put an input, and then sometimes it'll supply input. So in this challenge activity, we're working with very different types of variables, and we're doing an expression. So we still have our basic input, calculation or processing, and our output. So here we have an input of a certain value. We're going through our processing, and then we're going to do our output down here in 7. And in chapter 2, we don't, until we get to the lab activities, you don't have the option to code outside of that area that it gives you access to. So that's, you could put this over in Spider pie chart, but you can only code right here. So what it's asking for us to do is just to solve this math problem, just to write it as an expression and let the program do the rest. So finish the program to compute how many gallons of paint are needed to cover the given square feet of walls. Assume 1 gallon can cover 350.0 square feet. So this section here is really kind of story problems from math. And I don't know if they still call them story problems. Do they still call them story problems? Okay. Do you like story problems? No. I hated them in math. I remember that. They were confusing. So I think that's where a lot of people, get hung up in this section is you look at this as a story and not just a calculation. But read the story here because it does tell you exactly what your calculation is going to be. It tells you right up here. So we're finishing this program to compute how many gallons of paint are needed to cover a given square feet area of wall. So if I want to paint this whole back wall here, I need to know how many gallons of paint I need. And for every 350 square feet, I need 1 gallon of paint, is what this is telling me. So 1 gallon can cover 350 square feet. So I need to know how many square feet this wall is. So if this wall is 700 square feet, I need 2 gallons of paint, right? It's 350 plus 350 is 700. So the first thing we take in line 1 is how big is the area? How big is the area? Here, this is where I talked about everything being read in as a string. And because we're dealing with numbers, we need to change that. So it does it for us. It converts it to a float. And it also doesn't ask for a prompt. So when we run this program here, it's just gonna stop and let the user enter in a number. It's gonna convert that string, which would be, like in this example, it's gonna convert a string of digits from 1 0 to a number calculation. So we have to use float. We're using float here because we can have a half square foot. So you don't want to use the other number data type, which is an integer, because an integer is a whole number. If you can come up here, if you need to. The integer is a whole number. Float is a decimal. So make sure you understand the difference between the two. And then we need to write the calculation that tells us how many gallons of paint we need. That's what we're trying to figure out. So you go down here. Let me make this a little bigger. You go down here and we're going to use the variables that they've already set up. So my variable name, I can't say gallons equals something. I have to use the variable name that they've already created because I can't change that. So your variable name is gallons underscore paint. And we're going to set that equal to our calculation. So again, here it tells us what the calculation is. It says, so gallons is equal to, now if you're just reading that, like I just said, you can't use just the word gallons. You have to use the same variable name. So that's a common mistake in this one. Gallons is equal to the square feet divided by 350.5. So, and then it gives you an example. So if the input is 250 square feet, meaning it's not quite a whole gallon because a gallon will cover 350. If it's only 250, you need 0.714 something gallons of paint. You don't even need a whole gallon. So here, it tells you right here what our formula is. Square feet divided by 350.0. Square feet is represented in the variable called wall area. So you say wall area divided by 350.0. And that is it. That's the only line of code you need to code in this one. Again, here, what we've learned is you have, in Zybooks, when you're only plugging in or filling out the rest of one variable, you have to use their variable name. So I can't change this, just the area, because it has to match this one. And then read the story problem, break it down line by line, because it'll always give you your calculation. And then when you run this, if you haven't done this already, you can type it in at the same time, just run it. this particular lab, this challenge lab here, supplies us with input. So it says, okay, if the input is 250, here's my output. If the input is 578.6, I need 1.65 gallons of paint. By the way, this is a little excessive, right? You're not going to take that to the paint store and say, I need that much to paint. There's a function you'll see in this chapter that formats the data. It's called the format function. And you can format it to 2 decimals or 4 decimals or whatever to the right of the decimal place. So right now we're going to leave it like this, but in this example, we do not have to do any input. The programmer's iBooks puts it in there for us. All right, so that's the first one. That was program 241. 241. Somebody had a question on that one. Okay, the next 3, I'm just looking at my text message that they sent. Okay, the next 3 are all related. 261, 262, and 263, and these are a good set of programs to look at. Again, I'm not going to go through each section of this iBooks textbook because it's an interactive textbook. You need to read it on your own. So I'm not going to go from page to page here when we do talks like this. I'm not going to go from page to page and explain each section. That would take way too long because there's a lot of material. I want you to be more like you read this section and then come to me with the questions you have. And I can kind of start it off by sharing the most common questions I have. So 261, these would be the challenges. Two, 6, 1. Participation you can do. All right. All right, now this brings a little bit of your math skills where you need to know some basic things in math, which for some people can be intimidating. So that might be why I have those questions here, but let's see. This program, it's the same thing where it doesn't allow us to code everything. We just have to do the formula. And it does the input and the output for us. The other thing going on in this program is here we're using the .2f format function, and that will format your number to 2 decimal places. So in that last program, this is the syntax of how we would have done that. So make note of that, because when you're writing on your own, you're going to want to format. So it's you do a print statement, and then you do F at the beginning for format, and then at the end you say your variable that in curly brackets, you say the variable that you want to format, :.2f. 2 can change. So you can say .4f, and it would go 4 to the right of the decimal. So if we're working with, most of the time we do 2 decimal places when we round things. So that 2F is very common, but if you want to be more precise and do 4 decimal places or 3 decimal places, you could do that as well. But 2F is pretty common. So you're going to write a single statement that assigns average sales with the average of sales from number 1, 2, and 3 sales. So if your sample inputs are 3, 4, and 8, it's going to add up. You're going to find the average of that. So it does not tell you how to calculate an average. This is something that you should know. If not, just Google it. But you should know that. So if our input is 3 plus 4 plus 8, you add all those up, and then you divide by the number of values there are, which is 3, and that's your average. So your average is 5. So it gives us some examples. If it's 3, 4, 8, our average is 5. If you're entering in 1, 2, and 3, that would be 1 plus 2 is 3 plus 3 is 6. 6 divided by 3, so your average would be 2. So you add them up, divide by the number that there are. Some things that are already coded for you, average sales has to be initialized to 0 because it's going to be used in our calculation. And we create that variable and set it equal to 0 to kind of create a placeholder for it. So average sales equals 0. Number of sales are 3 input values. Here we're taking in whole numbers. If I'm working with money, I typically use decimals or floats, so I would make those floats. But here they're using as ints, and that's okay. But what that means is when they enter in your 3 sales, 3, 4, and 8, you can't enter in a decimal value. You can only enter in a whole number, or otherwise it'll truncate it. So we enter in 3 numbers. We're gonna and then line 9 does that format, and it prints out our average sales. So we're gonna figure out average sales using the variable names that they supply. Average sales equals, remember, and it talks about this in this chapter as you go through. Order of operations applies in programming languages. So parentheses around anything that you want to process first, always parentheses around that. So average sales equals number of sales from sale 1 plus num underscore sales 2. When you're typing like this and you're using variable names that they already supply, copy and paste if you need to, but double check your spelling on things, because that's where you get a lot of errors in the beginning. Like I almost said num sale 1 instead of num sales 1. And just leaving out that one letter would have caused my program to be incorrect, because my variable names don't match up. So be very cautious of that. Num sales 3, I want to add those up before I divide by 3. So I put parentheses around that. So remember PEMDAS, or remember your order of operations. Parentheses happens first. Multiplication and division happens next. Well, there's power, but your basic calculations, remember, anything in parentheses around what you want to process first. Then, if I didn't put parentheses here, I would have taken num of sales 3 divided by 3 would have happened first, and then I would have added number 2 and number 1 to it, and that would give me a wrong value. So parentheses around what you want to have at first, and we calculate average by first finding the total, dividing it by the number of numbers we have. So when you guys run that, it works. Does it work okay? It supplies some test data for us. Here we get more specific looking numbers, 3.33 instead of 3.33333336 or something like that. So make sure, you know, this is the benefit of using that 0.2f. All good on that? All right, the 362, somebody had a question about this, so we'll cover this one as well. And it's using a little bit more complicated numbers, I guess, words. You're still doing just one formula. And the formula is spelled out right here. So given the sphere radius and pi, write a statement to compute the volume of the sphere and assign sphere volume with that volume. So our formula is here. Volume of sphere equals 4 divided by 3 times pi times radius raised to the power of 3. One thing that does not work in programming languages is that caret symbol to take numbers raised to 3. So you cannot say radius, whatever the radius is, caret 3, which you could do in math, and that, you know, means raised to the power of 3. You cannot do that in programming language. So you can do something where if you had radius, you can use a function called math.pow. It's in a math header file, and it takes 2 values. One is the first number, and then second is the number that you want it to raise to. So this is just something, I can't use it in this program because I don't have the math header file and I can't code the whole thing. But if I were doing this outside of Zybooks, I would probably call math.pow and then take my radius and raise it to 3 this way. So there's built-in functions that will do that for us. But I can't use that here. I just have to take radius and multiply it 3 times. So here's my statement. It says if my sample input is 1.0, my sphere volume would be 4.19, and that's by taking 4.0 divided by 3.0 times pi times 1 raised to the power of 3. So when we first start this program, they've assigned pi a value. Pi is, again, something that's in that math header file, and you can just access it. So you can say math.pi, and it already has a value. You don't have to set it up like this. But we do in this example. So we say pi equals 3.14159. Sphere volume is nothing because that's our input. I mean, that's what we're calculating. Our input is sphere radius. So we're asking, what's the radius of this sphere? And so we're taking in some number. Again, with this example, Python or Zybooks is just supplying it. So our formula is sphere volume. Are you guys working on code over there in the corner? You guys working on code? Yeah. All right, just keep it down so it's not distracting. So we have sphere volume we're trying to duplicate this formula here, right here, because it tells us right there what it is. So, let's just do what it says here and see if we can get it to work this way. 4.0 divided by 3.0, and we want that to be in parentheses. And then we're gonna multiply that by pi. We're gonna multiply that by pi, right? So we're gonna say times, just use the asterisk symbol, pi. Pi in this formula, in this program, pi is a variable that we declared in line 1. So we can just say pi instead of putting 3.14159. The benefit of that is it saves time. So you just say times pi and it plugs in 3-point number. And then we're going to multiply this by the radius raised to the power 3. So again, I can't use math. I can't use that power function because I can't include that header file in this short example. So I'm going to say, in parentheses, I'm going to say sphere radius times sphere radius times sphere radius. So I'm not going to risk typing that wrong. I'm going to copy that and say that times that times that. Whoop. Maybe my screen's smaller instead of putting a parenthesis. Line 8 or line 9 in this example, now that I hit enter, line 9 just formats the answer to the right of the decimal. Okay, so let's see, we only had to code the formula. They gave us the formula here. We just had to convert their English words to code. So let's see if we did it right. Let's hit run. It supplies sample input for us. Well, I got all my blue check marks, so that's a good sign. All tests passed. Perfect. Those of you, oh, let's see, maybe I missed something. .92, got it. Okay, look at that one too. 2.92. Have you guys come up with questions yet from chapter 2 that you want me to look at? All right, is this good how we're doing it? Okay, all right. That one worked. Here's another one. I'll go through this one kind of quicker. It's the same thing though. It's the same concept where we have a calculation. We have variables at the beginning that we set up and declare. We do an input. And then we do a calculation, and then we do our output, and we round it to decimal places. The only thing here is it just has more words, some complex things. It has science and math together. It can be intimidating. So but it is just one formula that we're doing. And it gives us that formula right here. We're gonna compute the approximate acceleration of gravity for an object above the Earth's surface by assigning accel gravity with the result, with the expression right here. And then it gives the rest of this sentence, the rest of this story problem is examples. So it says, so if G is the gravitational constant of 6.7 or 6.673 times 10 to the negative 11th, then the mass is this value. So the rest of this is just confusing. Don't even need to read it, but that's how story problems work, right? They give you more information. You can read it, you can interpret it. It's just the solutions. But you just got to pick out the things in this story problem that we need. And one is, the only thing is that formula, which is right here for us. So, so if our input was 6.7 or 6.3782 E6, then this is going to be our output, because we're taking these variables, multiplying them together and then dividing by the distance raised to the power of 2. So we're just going to code that. We're just going to code that formula, and we're setting the variable accel gravity. It already tells us what to name our variables. So accel gravity is equal to G times N divided by distance raised to the power of 2. So we're going to just say G times M, put parentheses around it. So just like it says G times N, we're just saying G times N. G is actually this value. M is actually this value, but we created them and stored them as variables so we could reuse them a lot easier and use them over and over in our program. It's a lot easier to remember G than it is to remember 6.673E dash 11, right? G is a lot easier to remember. So, and then D raised to the power of 2 is, D is the variable that is our input, which is the center, distance to the center of the Earth. So we'll say distance underscore center times, it's raised to the power of 2. So we're going to say just times distance underscore center. And that's it. If it said D4, then in this place, we would just say G times N divided by distance times distance times distance times distance. Then we would do our print statement, which prints out the value accel gravity, and it raises it, or it formats it 2 to the right of the decimal. So let's give this a quick run. Acceleration of gravity. And then it shows our answer. Shows different values, testing with different inputs. Any questions there? All right, I had a question about 292, so let's jump ahead to 292. Oh, 292 is the math modules. So this is a good section to cover briefly before we look at that lab. Remember, well, we were just doing distance, we were just doing numbers raised to the power of 3, which was a mess, and then we were doing it raised to the power of 2, which was less messy, but you don't have to do it that way. You can use functions that are pre-built into your program that that we just access. So it's called the math module. We had to do it that way because we couldn't import the math module into our program. But let me launch up PyCharms real quick. But if you're coding and you have full control over what you're coding, then you can, anytime you want to use something in that header file, in that math header file, you can just access it and call it. It's pretty cool. So here's some of the things that are in there. Right here. So the seal is how seal X, that's math.seal, and then the number X is in all of these, the number X is the number that we want to manipulate. So a seal rounds up a decimal value. It rounds it up to the next whole number. Factorial, math facts. Oh, I hate math facts back from like 4th grade. It's horrible. Here's that power function, math.pow, x, y, x is the base number, y is the number you want to raise it to. So in our last program, we would have said we would have said pow, distance, comma, 2, because we had distance times distance. There's a bunch of things in this math header file. You don't have to memorize this whole chart. Just know that it's there. So if you ever get asked, or if you ever wonder in a program why something is rounded down or rounded up, or how they use pi, just know it's the code is already written, it's in the math header file, the programmer just has to access it. So this next section shows you how to do some of those things. So let's look at the question I had was on 292, which is a challenge activity. All right, this one's a good example because oh, I don't really like division in the mod operator either, but surprised nobody's had questions on that one. All right, so with this program 292, we are based on the information that's in the math header file. We're going to write a program that computes this formula, which is Z equals the absolute 292. Oh, this might be different for you guys. This one is different. This one, okay, every time there's 1, 2, and 3, notice there's different questions that come up. So you got to look at what question it is, or what they're trying to ask you to compute, and then go back to that math, that chart that we were just looking at, and use one of those math functions in there. Yep. I'm just hitting 1 again, so I can, like, if I just keep hitting it, here's some of the different computations. So you guys will get one of these. If you don't like the one you're given, hit the number again and it'll give you something different. So if I were given, if here's the one that I was given, z equals x, y, I need to go up to this here to figure out what function am I looking for that will take this number and raise it to the power of something. And that's the POW. So if this is the one I was given here, then my answer would be, okay, z is equal to math math.pow, and then you want to look back up this table to see how it's used. So math.pow is used by, it has 2 values. The first is the base number and the y is what it's raising to. Let's see if this is helpful. There is something on the internet that will give us more examples too. So if I want to use the exponent, if I want to use the exponent function, then this tells me a little bit more of how to use it. Or you could just Google how to use the exponent function in Python. That might be useful. But know that, I guess for this, and actually it's true in all programming languages, there's this math header file that we can use, and we don't have to rewrite the code, we just access these functions. So I went back up, I learned that I have 2 values in order to, I have x, and then, oops, I have x, and then I'm raising it to the power of y. That's just how I do it. Anytime you want to use one of these math things, notice the very first line of code is you need to import that math header file. So that says, okay, you can use any functions in math, but you have to import it. So if you don't import math right here, I cannot say math dot anything. It won't work, but it import it into my code. And then the rest is done. So here, and then I can check it. But let me look at, I know that's right. I'm gonna go off here and get another one. I'm gonna get y minus the square root of x. So we can look at how the square root function works, okay? So depending on the question you're given, here we're gonna take z is equal to y minus the square root of x. again, I don't have to, I just have to know that there's a function that will calculate the square root. So I go up here, I find the square root function. And this is how it's used. Square root, so math.sqrt. And then X is the number that you want it to go to do. So if you said square root 9 and you called this function and you put 9 in here as X, it takes that 9 and it throws it up to that math header file and it finds the square root of 9 and it sends it back to your program. So if you took 9, sent it up, 3 would come back, right? Because 3 is the square root of 9. So we're just gonna use it by saying math. So z equals y minus math, get in there, math dot sqrt, pass it X, close X, and then it'll, whatever's entered in line 3 is going to go up right here to say math dot square root, pass it X, get a value, and then we're going to subtract that from whatever the value of Y is. So let's check this and we can get an example. So if my input is 6 and 4, so if X is 6, let's write this down. If X is equal to 6 and Y is equal to 4, then what I'm really saying here, oh, I can't type back in this, but what I'm really saying here is Z equals 4 minus the square root of 6. And that's where I get 1.55. Yeah. Yes. I'll look at the absolute value. That's a good thing, but let's see. Let me go over that. Okay. When, just to finish up this one, when you go through here, you're gonna see these different things. So just test it out. If you get stuck, you can text me or ask me. This is Z equals, that's the square root. So you're gonna say math dot square root. And in this case, the X minus Y raised to the power of 3. This is what we have multiple things going on here. So in the square root function, we're going to say X minus, okay, now we're taking Y raised to the power of 3. So we'll say math dot how Y comma 3. And close out my parentheses. So when I went on to step 2, it's going to give us different math things to use, but this also shows us that we can use math functions inside of math functions. So I want to find the square root of X minus Y raised to the power of 3. So I want to say math.pow Y raised to the power of 3. Oh, good, I did that. Yours was wrong? Yeah.
correct. Correct.
Oh, on what you were showing me?
Yeah.
Okay.
Yeah.
How did you figure that out?
I don't think the obstacle will second one, has to be actually the obstacle in the first part.
Okay. Okay, cool. This last one here, this is just using, this is using 3 math functions. So it's just showing you can do that. So it's saying z equals the square root of the absolute value of x times math raised to the power of 3. So how would you write this one, you guys? How would you write this one here? We're going to use 3 functions. We use 3 built-in functions. The first one is this square root, right? And then we're going to use the absolute value, because that's what this is designed for, absolute value. And then we're using a power, which POW, and that will be y raised to the power of 3. So using these 3 math, how would we solve for z? The first one. Yep, math dot square root, so that's the first one. When you're using, whoops, z equals math dot square is QRT. When you're using multiple things like this, I open one parenthesis and I close it right away. Because if you open one and you don't have a closing parenthesis, you'll get lost in your code. All right, so what goes inside of that square root? Yep, so the next one is math dot absolute value of x times math dot pow of y comma 3. Yep. So it looks complicated at first. Well, I have an error, so let's figure that out. What did we do wrong? Oh, did I? Oh, that's why you should go back and look at the, thank you. You should go look it up. I did ABS, it's FABS. Fabs. Oh, no. Oh, I hope it doesn't give me a whole new thing. The only thing I'm missing is, try again. Oh, good. F. I just used the wrong function. There we go. Cool. So 293, this is the challenge activity. And this is, now that we've done that one where we are using those other things, we're gonna do the square root of this here. So just take it section by section. We've got x1, y1, x2, y2. Those are variables. We input the math header file. Our print statement is done and we're gonna figure out the distance. So everything in square root is let's see, we're taking this and we're raising it to the power of 2 plus this raised to the power of 2. So it'll start off by saying point. Let's try this again. You guys can tell me what to type next. Point distance equals what? Yep, math dot square root. I'm going to open and close that because everything else is in there. See, here's the open parenthesis. Here's the closing parenthesis. So what's inside the parenthesis first? Math.pow and then x2. Math.pow. And then we have 2 values in there. The first value is this. The second value is what we're raising it to. Did it get rid of my closing parenthesis? So math.pow, what do I want to say here? Not comma, we want to say x2 minus x1. Then what? Comma 2, yeah. So that's the first one. And then we want to add that, and we want to add the y's to it. So what's our y one? Math.pow. Comma 2. Close up that parenthesis. Look to this does it in the compiler as well. Okay, just trying to show you when you hover over or click on a parenthesis, you can see the matching one. You can see it matches over here. That's really useful when you're troubleshooting or you get a syntax error, because a lot of times when you have multiple parentheses in one sentence, they'll get lost. You'll forget one. So it's helpful to use that as a kind of a guide. All right, guys, let's take a quick break. I don't know how much more I'm gonna cover. I'm gonna look at my email and see if I have other questions that came in from email on chapter 2. You look through chapter 2 as well, but we'll have next week, so I can help you with some things next week, but let's take a quick break and I'll check my email and see if there's other questions. And you can look at the rest of the work and see if you have other questions you want to talk about right now, or you want to save them till next week. Let me pause my recording. Oh, I hate this two-way authentication.
I set my phone down, oh. What is my two-way authentication? One. 8.
Thank you for not throwing my cup away.
Yeah, I'm glad you got it back.
Have a good rest of your week.
You too, I'll see you next week. You all set for today?
Yeah.
It's cold out there, isn't it? All right, let me see. You too. I think I hit all the questions that I had from email, so I'm just gonna stop the recording for now. Come on, Zoom, where are you? Here we go.